So now I'm going to take a look at graphing this function. Now, I know previously they have the instructions that denote the domain and range and how it changes. But rather than that, I'm just going to graph this. And at the end, I may talk about how the domain and range changes with each transformation. When I take a look at this function, I'm going to choose to isolate the y to one side, simply because that's the way that we look at functions. And if I have a parent function, f of x is equal to the square root of x, well, what are the parameters a, b, h, and k for transformations? So I'm just going to write that a, b, h, and k. And when I do that, a is going to be -1, b is equal to 2, h, there is no h that is attached to the x, but my k is 2. Now, it's really important to keep this straight. I find that if I don't write out my parameters a, b, h, k, I make a silly error. So, for instance, a is equal to -1. This cues me to say that this is a reflection about the x-axis. So I take my points. I'm going to write functional notation here. Y is equal to the square root of x has point xy. So this is my image point notation. Now y is equal to negative square root x. I have point x comma -y. So that is, I'm taking this point right here, 1, 1. I'm going to multiply the y values by -1. This point 4, 2, I multiply the y values by -2. And this is what I have so far. Now, I'm going to go only with 3 points. Hope that's okay. So how did my domain and range change? Well, my domain didn't change because my x's didn't change. Pardon me. That's supposed to be a highlighter. My domain didn't change because my x's did not change, but my range was reflected. And the changes should be noted. Now I'm going to apply my transformation. So did a is equal to -1. Now I'm going to do my transformation b is equal to 2. Now, please be careful. I take my point and I'm going to compress it by a factor of 2. Or alternatively, I'm going to say I can stretch it by a factor of 1/2. So I'm just going to take my values, I'm going to take my x values, and I'm going to multiply them by 1/2. And that's all I'm doing here, and I end up with this nice shape here. And I made a mistake in my functional notation. This was compressing by a factor of 2 or stretching by a factor of 1/2. That is my new functional form. The next thing I'm going to do is I'm going to take my previous function and I'm just going to simply add 2 to it or shift it up 2 units. And I end up with 0.1/2 x. The x values stay the same, but my y values, I'm just going to simply add 2. 0, 0 turns into 0, 2. I think that's 1/2, -1, remains 1/2, and I shift that up 2 units. It's going to move to 1/2, comma, 1. To -2 will be shifted up into 2, 0. And there we have it. And what you can see from the graph is that my domain goes from 0 to infinity, and my range is -infinity to 2. So again, if you want to start graphing this without transformations, you would have to look at your radicand. Well, your radicand has to be greater than or equal to 0. If you divide both sides by 2, you'd have x is equal to or greater than or equal to 0. And in fact, what do we see on the graph? The graph has a domain where x is greater than or equal to 0. Now, once you know the domain, you can make a table of values, x, y, and you can just make arbitrary x values and figure out the y's. That's if you were to do it without transformations.